Discrete transformations is a branch of mathematics involving discrete elements that uses set theory was introduced by German mathematician G. Cantor. Introduced kitchen is the most relevant example for sets. Set can be represented by a roster or tabular form. So here the statement is converted as a roster or tabular form. Hello everyone, I am Shweta, Computer Science faculty, Vidhyaashram First Grade College, MYSURU. So welcome to my first session on discrete transformations. So this is your first semester B.C.A subject called Discrete Transformations offered by the University of Mysuru CBCS semester scheme. Discrete transformations is your core subject in first semester B.C.A and it is a scoring subject in first semester. So let's get started now. So first chapter is set theory. First chapter is set theory. It is all about the topic on sets. So first I would like to explain about the term discrete transformations. Discrete transformations is a branch of mathematics involving discrete elements that uses a algebra and arithmetic. And it is increasingly being applied in the practical field of mathematics and computer science. And it is a very good tool for improving reasoning and problem-solving capabilities. So, discrete transformation is a branch of mathematics and it is increasingly being applied in the practical field of computer science and mathematics. So, using this discrete mathematics, you can improve your problem-solving ability. So now I will discuss about set theory. So in my today's session, I will discuss the following topics: definition of set, representation of sets and types of sets. So what is set theory? Set theory was introduced by German mathematician G. Cantor, introduced of the concepts of sets. And set theory forms the basics of several other fields of study like counting theory, relations, graph theory and finite state machines. So set theory is a mathematical theory of well-defined collections of objects as a sets. So set theory is used as a foundation for many subfields of mathematics. So what is this sets? Sets is a collection of well-defined objects. Set is a group of collection of objects or numbers. So, we have so many definitions in sets. So, sets is a group of collections of objects or numbers. And or a set is a well-defined collection of distinct objects. So, set is a well-defined collection of distinct objects. So, what is this distinct objects? Distinct object means unconnected objects. So, set is a well-defined collection of unconnected objects. Set is also known as unordered collections of objects, also known as elements. Where do we use sets in our daily life? So, in shopping mall, you can see the image here. It is a unordered collections of objects and it is a well-defined collections of distinct objects. And so, set means is a unordered collections of elements, also known as objects. And also we have so many examples for sets in our daily life. So, you can see the image here. Set is the unordered collections of objects. It is a well-defined collections of objects. Bangle set and kitchen is the most relevant example for sets. So, set is an unordered collections of objects. So, this is the definition of sets. So, examples for sets: a set of all positive integers. So, set means is a collections of objects. So, we can take this example: set of all positive numbers, that means plus 1, 2, 3, 4, 5, etc. and set of all the planets in the solar system. So, it is a unordered collections of objects. And a set of all the states in India. So, it is a collections of objects. So we can call this is the set elements, and a set of all the lowercase letters of the alphabet. So it is an unordered collections of objects, or it is a well-defined objects, or also known as elements. And keep in mind, set can be denoted by a capital letters A, B, C, etc. So example, a set of all positive integers. So I will list out all the positive integers within a flower bracket. So set can be denoted by a capital letters. Within the flower brackets, I can mention all the set's elements. So example, set of all positive integers. So 1, 2, 3, 4, etc. So this is one set. Set can be denoted by capital letters within the flower brackets with comma. So this is an example for set. And set can be represented by a roster or tabular form or set builder notation. Very important question for 2 marks. What is roster form, or you can expect set builder form? So what is this roster form or set builder form? So the representation of sets can be divided into 2 parts, that is set builder form and roster form or tabular form. So what is this roster form and set builder form? So first one is roster or tabular form. What is this roster form? In roster form, all the elements of a set are listed. The elements are being separated by commas and are enclosed within flower braces. So in roster form, all the elements of a set are listed. The elements are being separated by comma and enclosed by flower braces. So in roster form, all the elements are listed. Example, set of vowels in English. So here I have one statement, set of vowels in English alphabet, that I will write it in a roster method. So here all the elements of a set are listed. So here in rostered or tabular form, you need to list all the elements. That means if your sets are in statements, you need to convert it into number of elements, or you have to list the elements. So set of vowels in English alphabet means we have A, E, I, O, U. So here the statement is converted as a roster or tabular form. That means the elements of a set are listed. Have listed the statement. Set of vowels in English alphabet. So have listed all the set of vowels in English alphabet. That is A is equal to A, E, I, O, U, enclosed within braces and separated by a comma. So another example, I have one statement here, set of odd numbers less than 10. Set of odd numbers less than 10. Less than 10, how many odd numbers are there? That is 1, 3, 5, 7 and 9. These are the odd numbers less than 10. So here I have one statement. This statement have converted as roster or tabular form. 1, 3, 5, 7, 9 enclosed within flower braces. So this is called as roster or tabular form. So we have another example for roster method. List the elements of the following set in roster form. The set of all positive integers which are multiples of 7. Set of all positive integers which are multiples of 7. So how to write this statement in roster form? Set of all positive integers which is multiples of 7. So here I have listed the elements. I have listed the set elements in roster form. So you can give this example for roster form or tabular form. Roster form is also known as tabular form. And next representation is set builder form. So set builder notation is a notation for describing a set by indicating the properties that its members must satisfy. So here instead of listing the elements, here I have to give the statements. So here the set is described as A is equal to X such that P of X. I will take this example. The set AEIOU. Here I have the list of elements that I will convert it into set builder notation. AEIOU is written as in set builder form. So A is equal to X such that X is a vowel in English alphabet. So this is a syntax for representing a set builder form, that is set A is equal to X such that P of X. So here I will mention the statement of a given set. X such that colon stands for such that X is a vowel in English alphabet. Instead of listing the elements, I am writing the statements in set builder form. It's very simple concept. In set builder form, we are not listing the elements. So instead of listing the elements, we are giving the statements for a given set of elements. In roster form, we are listing the elements. Instead of writing the statements, we are listing the elements in roster method. So in representation of sets, we have two methods, that is roster form or tabular form. Also, we have set builder form. So another example for set builder form, X is equal to Sunday, Monday, Tuesday, Wednesday, Thursday, Friday and Saturday. We have list of elements here. So how to write it in a statement called set builder form? X is equal to Sunday to Saturday. The set X contains all the days of a week. So instead of listing the set elements, you can write X contains all the days of a week. So how to write this in a set builder form? So X such that X is a day in a week. So in set builder form, instead of listing the elements, you can write the sentence. So this is your example for set builder form. So next concept is some important sets. So in set theory, we have some important sets. So N is called as the natural numbers. So N is equal to 1, 2, 3, 4, etc. And Z is called as set of all integers. Set of all integers means it can be positive integers or negative integers. So we can represent it by Z. So natural number is represented by N. And Z plus, the set of all positive integers is represented by Z plus. And the set of all rational numbers is represented by Q. And the set of all real numbers is represented by capital R. And the set of all whole numbers is represented by W. So these are the common, very important sets we are using in set theory. So next important concept is cardinality of a set. So what is this cardinality of a set? Cardinality of a set is denoted by mod S. So what is this cardinality of a set? It is represented by mod S. The cardinality of a set means the number of elements of the sets. Very simple concept. The cardinality of a set means the number of elements of the set. So here, how many number of elements are there? We have 5 number of elements. So this is called as cardinality of a set. Cardinality of a set is denoted by S, and the number of elements of the set is called as cardinality of a set. Example, if a set has an infinite number of elements, so it is denoted by the symbol mod S is equal to infinity. So here I can write the cardinality of this set mod S is equal to 5. We have 5 number of elements. This is called as cardinality of a set. Examples, 1, 4, 3, 5 is equal to 4. So how many number of elements are there? 1, 2, 3, 4. So we have 4 number of elements. And 1, 2, 3, 4, 5, etc., etc. So how many number of elements are there? We have infinity number of elements. Next example is set A is equal to 2, 4, 6. contains 3 elements. Is it right? So here we have 3 elements, 2, 4 and 6. The cardinality of this set is equal to 3. And next important concept is types of sets. So we have different types of sets, that is null set, singleton set, finite set, infinite set, equal sets and equivalent sets, subset, power set, proper set, improper set and universal set. So we have different types of sets. Let us understand one by one. So first type we have null set. Null set is also known as empty set. 2 marks question. What is null set? Give an example. Null set is also known as empty set. So what is the definition of null set? A set which does not contain any element. A set which does not contain any element means it is called as empty set or null set. It does not contain any elements. So it is an empty. The set, it does not contain any element means we can call it as it is an empty set, or we can represent it by phi, or the null set or the void set, and it is denoted by phi symbol. Null set also known as empty set or void set also, and it is read as phi. This symbol is phi symbol. If a set which does not contain any element means we can represent it is null set. An empty set is a finite set. An empty set is called as finite set. So because we can call it as it is a null test, there is no number of elements means we can call it as it is a finite set. So empty set, this is one empty set. This empty set is called as a finite set. Since the number of elements in any empty set is finite, that is 0. Here there is no number of elements, so I can call it as is a finite set also. So null set is also known as empty set or void set. If a set which does not contain any element is called as null set or empty set. Example, the set of whole numbers less than 0. It is obviously not possible. The set of whole numbers less than 0. So the set value is null. There is no whole numbers less than 0, right? So it is an empty set. So this is one best example for null set. The set of whole numbers less than 0. Clear? So this is called as null set or empty set or void set. So it is represented by the symbol called phi. And the next type is singleton set. Singleton. A set which contains only one element is called as singleton set. A set contains only one element. Set contains only one element is called as singleton set. So example, we have one statement x such that x is neither prime or composite. So we have only one prime or composite number, that is 1. So answer is 1. So singleton set means a set which contains only one element. Only one element is called as singleton set. And next type is finite set. What is this finite set? We have number of elements in a set. So if you are able to count the set elements, that is called as finite set. So here I have one set elements. I can count these elements A, B, C, D, right? So this is a finite set. So what is the definition? A set which contains a definite number of elements is called a finite set. A set which contains a definite number of elements. Empty set is also called a finite set. So empty set means there is no elements in a set. We can call it as it is a finite set also. So finite set means A set which contains definite number of elements. So if you are able to count the number of elements, we can call it as finite set. Example, the set of all colors in the rainbow. So here we are able to count the colors in the rainbow. So is it finite set? Yes, of course, this is finite set example. So I can call this is a finite set. And another example, n is equal to x such that x belongs to n, x is less than 7. So x less than 7 means, so we will get only 6 digits, right? And a is equal to, we have number of elements 5, 7, 9, 11. I am able to count this number of elements, so I can call it as it is a finite set. And b is equal to 4, 8, 16, 32, 64 and 128. So easily I can count this number of elements, so I can call it as is a empty set. So empty set is a set which contains a definite number of elements. This is called as empty set. So null set or empty set is a finite set. And the next type is infinite set. So what is infinite? So we are not able to count the number of elements. That is called as infinite set. The set whose elements cannot be listed. The set elements which cannot be listed is called as infinite sets. Set containing never-ending elements. So set containing never-ending elements is called as infinite sets. So here I am not able to count the number of elements in a set. We can call it as infinite sets. So infinite set means whose elements cannot be listed, or set containing never-ending elements is called as infinite sets. And next is equivalent set. So what is this equivalent set? Two sets A and B are said to be equivalent if their cardinal number is same. Already I have discussed cardinal number. Example, A is equal to 2, 4 and 6. What is the cardinality of this number? So mod A is equal to 3. We have 3 number of elements. So cardinality of this number is 3. So here equivalent set. In equivalent set, two sets A and B are said to be equivalent if their cardinal number is same. If their cardinal number is same means we can call it as it is an equivalent set. So we can represent it by n of A, n of B, etc. So this is equivalent set representation. The symbol for denoting an equivalent set is, this is the symbol for representing equivalent set. Example, if A is equal to 1, 2, 3, what is the cardinality of this set element A? So here I have 3 number of elements, so n of A is equal to 3. So this is an equivalent set representation. And B is equal to P, Q, R. We have 3 number of elements, so n of B is equal to 3. You just compare this set elements of A and set elements of B. So cardinality is same in both set A and B. Therefore, A is equivalent to B. If the cardinal number is same in a set, we can call it as it is an equivalent set. And next we have equal sets. So what is this equal sets and equivalent set? In equivalent set, the cardinal number of sets is same, but in equal set, two sets A and B are said to be equal if they contain the same elements. If they contain the same elements, every element of A is an element of B. Please understand the concept properly. Every element of A is an element of B, and every element of B is an element of A. We can call it as equal sets. But in equivalent sets, all the cardinal of set A and B or C should be same. But in equal set, all the elements of set A is an element of B, and all the elements of B is an set element of A. But in equal set, every element of A is an element of B, and every element of B is an element of A. This is called as equal sets. Example, A is equal to PQRS, we have 4 sets, and in B we have PSRQ. You just observe these two elements, PQRS and PSRQ. Both are same but not in order. So in these two sets, both the elements are same but not in proper order. So we can call it as it is equal sets. Keep in mind, in sets, all the elements or objects are not in proper order. Then also we can call it as a set. So this is the representation of equal set. A is equal to B. Because every element of A is an element of B, we can call it as is an equal set. See the difference of equivalent and equal set. So here both the elements are same in equal sets. But in equivalent set, all the cardinality should be same in equivalent set. So this is your equal set and equivalent set. And next type is subset. Very important question for 2 marks. What is subset? If each element of A is also member of a set B. If each element of set A is also member of set B, then set A is called subset of B. Example, here I have set element 1, 2, 3 and in set B I have 1, 2, 3, 4, 5, 6. Here the number of element is 3 but in B the number of element is 6. Understand the concept? If each element of set A is also a member of set B. So in set A I have 1, 2, 3 and also in set B I have same element called 1, 2, 3. So I can call it as A is a subset of B because each element of set A is also a member of element of set B. I can call it as A is a subset of B. A is a subset of B. So you can represent it by this symbol. A is an element of B. So here you can observe this. B is a subset of A because every element of B is also an element of A. So I can call B is a subset of A. B is a subset of A because every element of B is also an element of A. I can call it as subset. So this is called as subset. Very important question for 2 marks. What is subset? Give an example. So you can write any example for subset. So next topic is types of subsets. So in subsets, we have 2 types, that is proper subset and improper subset. Proper subset and improper subset. So what is this proper subset? So a proper subset is one that contains few elements of the original set, whereas improper set contains every element of the original set along with the null set. Already I have discussed the subset. So in subset we have 2 categories, that is proper set and improper set. So let us understand with an example. Proper set. If A is a subset of B, then set A does not contain every element of set B. If A does not contain every element of set B, I can call it as this a proper subset. Then set A is called proper subset. Example, if A is equal to AEI and B is equal to AEIOU. So here in set A, I have 3 elements. In set B, I have 5 elements. So what is the definition? Set A does not contain every element of set B. This set A does not contain every element of set B. Then I can call it as it is a proper subset. So this set A does not contain every element of set B. So here I have only AEI, but in set B I have AEIOU. Set A does not contain every element of set B. Therefore, I can call it as proper subset. And next important concept is power set. Very important concept, power set. You can expect this question for 2 marks. What is power set and give an example. So what is power set? The collection of all subsets of a set A is called the power set. The collection of all subsets of a set A. Collection of all the subsets of A is called as power set. If the cardinality of a set A is small n and cardinality power set is represented by 2 power n, as every element has 2 options, either to belong to a set or not. So it is denoted by P of A. So power set is denoted by P of A. Example, so here I have set A is equal to 1, 2, 3. How to write it in a power set? So it is represented by P of A, P of B, P of C, etc. So A is equal to 1, 2, 3. Cardinality is, so mod A is equal to what? 3. So cardinality of this set is 3. I have 3 number of elements. So what is the cardinality of a power set? So it is represented by 2 power n. So n is equal to 3. So 2 power 3 is equal to, you will get 8 set elements. So if your cardinality is 2, so you will get 2 power 2 is equal to 4 number of elements. So in this example, so you have cardinality is equal to 3. So you will get 8 number of sets. So how to write this power set? So you have to start with null set 5, comma, the first element is 1 and the second element is 2 and the third element is 3. Starts with null value, open double flower bracket and null value, comma, first element, second element and third element. And compare this first element with second element and third element. So 1, 2, 1, 2, 1, 3. So totally you will get 8 possible set elements. 1, 2, 3, 4, 5, 6, 7, 8. So 2 power 3 is equal to 8. So I'll give one more example. If set B is equal to 2, 4, here I have only 2 set elements, 2, 4. So what is the cardinality? Mod B is equal to 2. So 2 power 2 means you will get 4 number of elements. So you have to start with the 5, that is null set, comma, first element is 2 and second element is 4 and compare this first element with second element, that is 2, 4. Is there any other possibilities to compare with the third element? No, I have only 2 elements. So 1, 2, 3, 4. So I have completed with the 4 number of elements. So this is your power set. So P of B is equal to 5, 2, 4 and 2, 4. So we have to closed with double flower bracket. So this is called as power set. And last topic is universal set. What is this universal set? A universal set is a set containing all elements of problems under consideration. So it is denoted by U. So set contains all the elements of other sets. Example, A is equal to 1, 2, 3, B is equal to 4, 5, 6. We have 2 sets here. So what is the universal set? So universal set means a set contains all the elements of other sets is called as universal set. Example, in set A, I have 1, 2, 3. In set B, I have 4, 5, 6. The set contains all the elements of other sets. So U is equal to 1, 2 and 3, 4, 5 and 6. This is called as universal sets. A set contains all the elements of other sets is called as universal sets. It is denoted by U. So all these types of sets is very important while doing the problems in set theory. So today we learned the definition of set and representation of sets, that is roster form and set builder notation, and also have discussed types of sets. So we have null set, empty set, singleton set, infinite and finite set, and also we have subset, proper subset and improper subset, and power set and universal set. And also I have discussed subset, types of subset, power set and universal sets. Please practice all the types of sets. So in my next session, I will come with a new concept called set operations. Thank you.